the other one you're going to keep, and that'll be your answer.
It can't be more than 2.7.
Right, and yeah, you can't have both answers. One of them is going to be wrong. For instance, is it possible to have a negative pressure? So if you get an X that gives you a negative pressure, that one's the bogus one. All right, so I'll give you a couple minutes. Go ahead and use the quadratic formula and solve for X. Now, all right, just go ahead and solve for X. Then we'll talk about it. There is not. Do the quadratic formula.
You can factor it.
Or you can grab
Complete the square.
Got it.
No, stay there. Don't do anything.
Work together if you want to. Talk it out. Sing the Notre Dame fight song.
X equals negative b plus or minus square quantity b squared minus 4ac all over 2.
No, divided by.
It's all
Oh,
over.
you're singing it wrong.
No, it's all over. That's how I learned it. Mr. Moore, is it all over 2a or is it divided by 2a?
I learned it divided by.
Either way.
Frankie agrees with me.
Yes, Lana?
It's.
I don't know, it fits. That's not really, I mean, it's the tune of the fight song, that's not what they sing. I don't know what the lyrics of the fight song is. No, you're using the tune of it, that's all.
That'd be really dumb. I feel like
Yeah. So when the team scores a touchdown, they sing the quadratic formula. I don't think so.
I think that'd be fun.
Oh yeah, Mr. Moore, I figured out how to play the scientific method song.
Change that number for me.
Song?
Yeah, the scientific method song. You never heard it?
No, let's wait until after class.
Okay.
We'll spare the viewers of our
Oh,
video.
okay.
Yes, sir? I am not monitoring your calculator. You just can't use it during the multiple choice part. I still need to see your work.
Wait, so I can cheat?
No, you can't cheat.
Dang it.
Yeah, but like, no.
Get a value of X.
Oh, wait. Is it?
If you're having trouble getting the right answer, the quadratic formula is set up here on the board in green.
Can I just take? I got my point. Who's like 1.5?
I want to caution you too. Listen to this. You're going to get an answer of 1.5 for X. Look at your answer choices. Is 1.5 there as your answer choice? Yes. Be very careful. Look what's in the box here. This is what we're trying to solve for. So when you get an answer after doing all this work in the quadratic formula, you think, oh, 1.5. Oh, that's A. Right, it's A, I think.
Yeah, it's A.
Be careful. You know how tricky these question writers are. You make sure that you follow the problem through to make sure you get what it asks for.
Oh, yeah. So you do 2.74.
Minus that, yeah. So yeah, get 1.5 for X, subtract from 2.74, and that's our answer.
Oh my god, I was right. I used to know like 2 months ago and I forgot.
I need to program.
Oh wait, Mr. Moore, you got your pass back.
Ended up on my mailbox.
Oh, okay. So nobody has to use the gas shut off then.
All right, gang, we got to move on. Sorry. Is there anybody that has any questions? You can't get this for whatever reason?
Wait.
One day a year, I get that fight song in my head. Can't get it out. That's this day.
You're welcome.
Can we move on, please? All right. The final answer is the x value you get down here is 1.5. By the way, I mentioned that you're going to get one bogus x answer. What was the bogus one? Anybody have it?
Like maybe 3 points.
Negative something? So it's going to be 2.74 minus a negative number, which causes the pressure to go up. Can the pressure possibly be higher than what it was initially? No. It's a bogus answer.
Logical.
The good x value is 1.5, and the answer then is 2.74 minus that 1.5, which is 1.24. Negative 3 point something.
Extra more. For the test, how are we supposed to do a square root of all this?
You're not gonna be that mean. So
Yeah, he
We
is.
know that.
Of course he is.
Of course he's not. Of course he's gonna be that.
He's
This
not.
takes practice.
Wow,
Do it.
seriously?
Well, my mom actually taught me how to do
1.8
it.
squared is
He's
what?
not for real.
3
1.8
point
squared.
something?
Well, it's less than 2 squared. It's like 3 point something, right?
You're not for real.
3.9 something, I think.
4 times.
Oh yeah, I know.
3.96.
That's about
How does this
minus.
work?
That's
Did I
about
do something
minus
wrong?
20, which means you would get a.
You see that we said
Huh.
20-ish.
Oh, because that number right there is negative. Yeah, because I was looking at this thinking, okay, 3 minus 20 is negative. How can you take the square root of negative? That's got to be a negative 4.93 to make it positive.
Yeah.
Sorry. Anyway, yeah, you can just estimate your answers. You'll be fine. Or there'll be a simpler way to do it.
Maybe he'll just.
Let's move on to number 12. The answer was
1.24.
1.24. Minus 4.5.
Now that sounds.
All right, and me too. Got that okay, bro? Yeah. Number 13. No, number 12, sorry. Okay, for this reaction, let's go ahead and make up an ice table. But I want to do this together because there's something that I think is important that you can't overlook. It gives you the moles of the two reactants. Do we put moles into the ice table? Why not?
Because you're trying to find the pressure
K value is either the ratio of the pressures or the ratio of the concentrations, not moles. The ratio of the concentrations is not necessarily the same as the ratio of the moles. So if you're given moles, you have to find either pressure or concentration. Now the problem is talking about, it says the equilibrium constant is 18. Do they mean Kp or Kc if they say the equilibrium constant?
KC.
They mean Kc. If they don't specify Kp, it means Kc. They have to make it very clear they're talking about Kp. Lena?
So if they give you KP, do you put concentrations into the table?
They give you Kp, put the pressures into the table. Like if they give you moles, use the ideal gas law and find the pressures of what you're given and use that.
So you always put pressures.
If it's Kp that they give you, yes.
But if they give you KC,
Like we want to find Kc here. No. Oh, they do. They give you Kc. So you're going to use concentrations in your ice table.
oh wait,
Kc is the ratio of the concentrations at the end. So since they gave us Kc, we're going to use our ice table with concentration numbers.
okay, so
Okay.
whatever they give you.
Yes, right. So they didn't give us concentrations though, they gave us moles. Well, we can find the concentrations though, so we have to. The concentration of SO2. We had 1 mole of SO2 in a 20-liter container. So what's the concentration of it? 1 over 20, 0.05. What about NO2? We had 2 moles in 20 liters, 0.1, not 0.01, 0.1, 1/10. There's our concentrations of the two reactants. What's the concentration of the products initially? Sometimes you'll have a concentration of products. In this case, we don't. So that's 0 and that's 0. You okay with that? So we know this reaction is going to shift to the right. What's the matter?
Okay.
All right, so the K value they give us is 18. I'm going to go ahead and write that up here. K equals 18.0. What concentration of SO3 will be present at equilibrium? This thing right here is what we want to try to find. We can go ahead and complete the rest of our ice table. We don't know all the numbers for it, but we can at least put a symbol in there. We know that's going to shift right, so the reactant concentrations are going to go down. Yes? That's going to go down by some amount X. This one is also going to go down by some amount X. They react in a 1-to-1 ratio. They go down the same amount. What's going to happen to the SO3?
They're going to go up
It goes
by
up by
X.
X. And then NO is going to go up by X as well. So the concentration at equilibrium of SO2, I don't know what it is yet, but I know it's in terms of X, 0.05 minus X. 0.1 minus X for NO2. And then SO3 is X and NO is X. Yes, ma'am.
So are they zero only for the initial because they haven't started the reaction?
Yes, that's right. That's right. So we're going to try to solve for X here. Kc equals 18. And that's equal to products, which is X squared, over reactant, 0.05 minus X, and 0.1 minus X. Solve for, there's lots of X's in here. Solve away.
Isn't it the? You want to get?
Yes, yes, that's right.
Isn't
If it was a 1-to-2 ratio, that would go down by X, that would go down by 2X. Yep. We'll see that in the next example. How do you like the math in this one?
You're brutal. It's not fun.
Benit?
I kind of did it by pressure. Would that like destroy me?
You'll have to change it. Yes, I think so.
Because I ended up doing it by pressure. And I
Because
got,
you know what? Kp equals Kc in this case, so no, you're gonna have the same K value.
I know, right?
because then I got like 2 positive.
But I have to tell you this. There's a way easier way to do this without doing any math at all. Look at your 5 answer choices. 4 of them can be thrown out. Sounds so good. Which is the correct answer? Not E.
Never mind. Wait.
Ew, but he's not
Oh, never mind. D.
All right, please disregard that person.
Uh,
4 of the 5 choices are no good. That means there's only one good choice, Varun.
Is it A?
Yes, why?
Because it's less than 0.05.
You can't have a negative concentration. So when you take 0.05 minus some number, it's got to give you a positive concentration for that first reactant.
Will you do this on the test?
Right?
definitely.
Somebody earlier today said, well, wait a minute, couldn't we just plug in those 5 answer choices and see which one comes up, when you plug them in, comes up with K? Yeah, I guess you could. You could do that too if you don't want to do the quadratic formula. I don't know what would take you less time. But anyway, yeah, A is the only good answer, so that's the right answer.
Wait,
Let me
could
check.
you re-say that again? I didn't get that.
Which part?
Why is A the only right answer?
Because when you get X after doing all this, you're going to get some number. And take and subtract it from 0.05. This SO2 has to have some positive concentration at equilibrium. The other choices for X give you a negative concentration when you subtract 0.05.
Which
So the
means
answer
that,
is
you know,
A.
like, you can't have a negative for the constant.
Right. Yep. All right, next one. Would you, and so you could have calculated that mathematically, it just takes you a while, it's no fun. Number 17. Number 17 is actually a break, it's easier than those other 2.
Oh, you're so nice.
It's okay.
Thank you.
So we have NO2 yields N2O4. This one's kind of weird, but it's not hard. Set up your ice table, and then you'll look at me and say, oh yeah, that's weird.
And then, oh yeah, it's easy, right?
Hope so.
Or maybe it's easy for him.
Everything's easier. It's a pumpkin.
Precisely.
It's Mr.